Hi, welcome to science subject, which is a very exciting part of the application of the Newton's laws of motion. Okay, so this type of problem or drill set, we have a lot of set of drills that we can see in our Moodle or in our portal, and that deals with how we will solve a certain problem which is applied or given and can be indicated with a set of lessons that we have. So be cautious about that and be aware that in every problem, in every topic that we will encounter in our Moodle or in our portal, there is an incorporated drill set, particularly when referring to practicing solving a problem. Okay, so this time, our drill set is all about the Newton's laws of motion, the application of Newton's laws of motion. Okay, let me read first our problem. An object weighing 10.0 kg is acted upon by two forces, as shown in the figure. If the floor is frictionless, find the measure of the tension when the object is A, accelerating to the right at 3.0 meter per second squared, and accelerating to the left at 3.0 meter per second squared. We have our first rule. So, first rule in solving a problem is we need to analyze it. Do not arrive and look for the answer. Forward answer. That's not proper. We need to analyze the problem first. Analyzing the problem is the solution and the key step in understanding and arriving at the right solution. Okay? So, an object weighing 10.0 kg. What is 10.0 kg thereafter? We can think of it as a, of course, 10.0 kilogram is a unit for mass. Tama? Any type of 10 kilogram, 100 kilogram, or so on, kilogram is a unit for mass. May pagkakakilanlan, kumbaga. Next, 3.0 meter per second squared. Meter per second squared in our grade 7 science, we are familiar with that. That is the unit for acceleration. Okay, now at this point in time, we should have an idea. We have an idea what problem are we dealing with. Okay, so next, analyze the figure given. This figure in physics is what we call the FBD, or the free body diagram. So free body diagram is an illustration of the system or system of forces that we can further conclude should say that might be acting on an object, whether it is stay at rest or in motion. That's a free body diagram, an illustration, the identification of forces acting on an object. Okay, so we have our first rule. Our first unknown is accelerating to the right at 3.0 meter per second squared. Since the object is accelerating to the right, then F net, or the total force acting on an object, is equal to T minus 40 newtons. That is our F net. We will think for a formula, and that formula must satisfy our equation. Kilogram as mass, meter per second squared as acceleration. So our missing link for this, we are familiar at our background information regarding with that the second law of motion deals with the variables of force, mass of an object, and acceleration. We can state that the second law of motion states the following. So second law of motion states that the force of an object is equal to the mass multiplied by the acceleration of an object. checking our given with our problem. To our problem, sorry. So, mass is given, acceleration is given, F net is given. Thereafter, we can look for the unknown value. Sorry. Okay. So, let's all continue. So, F or the F net is equal to T minus 40. This is our F net. So, we need to look for force. So, therefore, T minus 40N is equal to the mass of an object. Our given mass with this problem is 10.0 kilogram or 10 kilogram multiplied by the given acceleration, which is acceleration of 3.0 meter per second squared. Remember that 3.0 meter per second squared is the acceleration of an object to the right. Okay? To the right. And we have our rule. Accelerating to the right, the tension must be greater than 40.0 newtons or the applied force. Continue. So, T minus 40N is equivalent to 10 kilogram multiplied by 3.0 meter per second squared. So, 10 multiplied by 3 is 30 kilogram meter per second squared. In our previous discussion, we also understand the equivalent unit. The equivalent unit for 1 Newton is equal to 1 kilogram multiplied by meter per second squared. We are familiar with this. This is what we call equivalent unit. Okay? And therefore, 30 kilogram meter per second squared is safe to say is the same with 30 newtons. So let's rewrite it. T minus 40 newtons is equal to 30 newtons. Is that clear? Okay, so T minus 40N is equal to 30 newtons. We need to isolate the value or transpose para makuha natin yung unknown natin, which is the T. So therefore, T, or the tension force. T or the tension force will be resulted when we add 40 newtons plus 30 newtons. Recall your grade 7 algebra kung bakit naging ganun yung ating sagot. So thereafter, our tension force is also equal to 70 newtons. That is our answer when we are looking for the right side. This is the tension at the right. Okay, is that clear? Next, we have our second drill, accelerating to the left. When it is accelerating to the left, 40 newtons must be greater than T. So therefore, if it's greater than T, that F net is equal to 40 Newton minus T. Applying the second law of motion, which is the law of acceleration, that force is equals to mass multiplied by acceleration. Right? Then thereafter, force, which is 40 newtons, which is 40N minus T, is equivalent to mass of an object, which is 10 kilogram, multiplied by its acceleration, which is 3.0 meter per second squared. Okay, so let's all solve. Continue solving this problem until we arrive with our solution. 40 newtons minus T is equal to 40 newtons minus T is equal to 30 newtons. Transposing the value to the other side of the equation, we will arrive with this, that tension force is equal to 40 newtons minus 30 newtons, and tension is equal to 10 newtons. This value, or this tension force, is at the left side of our free body diagram. So again, to have a short recap regarding with what we are dealing with at this time, we solved the following problem involving the second law of motion, the application of second law of motion. And the problem deals with two things. First is whether the object is accelerating to the right, or letter B, the object is accelerating to the left with the same acceleration value, which is 3.0 meter per second squared. What will be the tension force? That is our problem. Our rule is that when the object is accelerating to the right, tension must be greater than 40.0 newtons. Thereafter, any type of force which is ahead from the right side of our given value, T must be greater than 40. That is our rule. T must be greater than applied force. If it's to the left, applied force, or the 40 newtons, must be greater than the tension force. Okay? That's all, and thank you very much for listening. God bless.